In this video, we're going to go over linear patterns. So let's say you and 3 friends go to a restaurant. And the way the restaurant works is the 4 of you are placed around a table, kind of like that. So the circles represent the chairs, and the table is represented by a square. Now, let's say while you're sitting there, some of your friends show up. And the restaurant does something sort of strange. They add some more chairs and they add another table so that after your friends are seated, everything looks kind of like this. So now there are 2 tables and 7 chairs. Okay, so 2 tables and 7 chairs. And you can see the way that person in the middle there is kind of, well, maybe that's you, right? Because now you can eat off both tables, which might be kind of nice, but maybe not, I don't know. So then some more friends show up, and again the restaurant does the same kind of thing, so that now the configuration is like this, with 3 tables, and gosh, how many chairs is that? How many chairs do you see? 3 along the top, 4 in the middle, 3 along the bottom, so 3 plus 4 plus 3, that's 10. Okay, so let's just say for the sake of argument that some more friends show up, and you might kind of see where this is going. In this case, we have 4 tables and some more chairs. So again, counting the chairs one by one at this point gets really annoying. So you might want to try and shortcut that. So again, you might say, well, there are 4 along the top, 4 along the bottom, 5 in the middle, something like that. So you get 13. So just to summarize, or just for yourself, take a moment and think at each stage of the game here, for each table, how many chairs were there in this restaurant? Okay, so you probably figured out that in the first configuration we had 4 chairs, in the second we had 7, in the third we had 10, and in the fourth we had 13. Okay, easy peasy. Okay, so knowing that, it might be kind of nice if we sort of organize this a bit so that we get away from this picture of chairs and tables and kind of organize things. So one way you might do that is by putting it into a table. So here we have a table, and in this case I've just gotten away from the idea of chairs and just gone back to circles, but I hope that you're okay with the idea that we can look at this and say, hey, wait a second, at stage 1 I had 4 circles, or chairs if you prefer. At stage 2 I had 7. At stage 3 I had 10. And stage 4 doesn't show up, right? Stage 4 doesn't show up. But stage 4 had 13. So you got to have a think now. How many chairs would there have been at stage 5? We didn't actually go that far in the picture, but how many would there be in stage 5? Furthermore, we can also go backward and we can say, hey, how many would there have been at stage 0? That's kind of weird, right? What does it mean to be stage 0? But for our purposes, it doesn't really matter. All we're really looking at is, can you follow the pattern? Can you follow the pattern? So try and think about that. Okay, what I hope you realize after a while is that since you're adding 3 each time, to go from 3 to 4, you add 3, so you're at 13, and then you would add 3 more. So at 5, stage 5, you would have 16. And likewise, if you had gone backward from stage 1 to stage 0, you would take 3 chairs away, which would leave you with 1 chair. So that's kind of the idea. Now I wonder if you can have a think about how could you get to 50? In other words, if you had 50 tables, how many chairs would you need to accommodate all of your guests? Another way that you might think about this is by taking the information from your table and putting it into a graph. So in this case, I'm going to take the information that's in my table of values, and I'm going to plot it as points on a graph. Okay, so I think this will be okay. So at stage 0, I have 1. Stage 1, I have 4. Stage 2, I have 7. Stage 3, I have 10. And stage 4 and 5, unfortunately, are off the bounds of my chart here. So that's not too bad. But nonetheless, you can see, hopefully, that I have 4 points here. And I could actually draw a line through those points. So I'm going to try and draw a line through those points. And in this case, I'm going to start. That you might try to do with these points is you might try to draw a line through them. So I'm going to try and do that now. And I didn't succeed particularly well. That's okay. There we go. That's not too bad. So in this case, you can see that my line passes through all 4 of the points. And because it passes through all 4 of the points lie on the line, this is a linear pattern. The last thing we want to do is we want to write an equation. And this equation is basically representative of the information that's in the table of values, and also represents what we see in the graph, and really also represents what we saw with the tables and chairs back at the beginning of this whole thing. So the equation is going to be a relationship, and the relationship is going to be between 2 variables. Now in the table of values, we chose stage number and number of circles as our variables. So to make things easy on ourselves, we're going to change those to letters. Now which letters you choose doesn't really matter, but just to keep things kind of the same, I'm going to choose S for my stage and C for my circles. Okay? So if that's the case, then C, which is the number of circles, equals 1, because that's how many circles I start off with at stage 0, plus 3 more circles each time I increase the stage. Having worked out this equation now, it becomes a lot easier to figure out how many circles or how many chairs I would have needed at stage 50. Right? So with the equation now, what I can do is I can say at stage 50, that would mean that S would have a value of 50. So I'm trying to work out how many circles would I have if I started off with 1, and then I added on 3 more 50 times. Okay? So with that being the case, I would have C equals 1 plus 150, which equals 151. And that's it. Here's a picture of my friend's dog. Thanks for watching.